Hello students, welcome to Maths for NEET Physics lecture series. Today we are going to start trigonometry. Total complete trigonometry will be in 2 or 3 lecture series. So first of all, we'll learn what is trigonometry and why do we study that. So this is a very nice statement written here. For physics, trigonometry should not be studied as abstract identities, but it must be positioned as a tool for resolving physical quantities. So physics is all about game of different types of physical quantities. We play with two or more physical quantities to give birth to some new physical quantity or to find some new physical quantity. So many times it happens that we need some physical quantity A in some particular direction. Like suppose that we want to calculate displacement in this direction and some particle is moving in this direction. So clearly you can say this particle velocity is in this direction, but we need displacement in this direction. And suppose that angle between them is theta. So after studying trigonometry, we will be able to relate if this particle is moving in this direction with velocity v, what will be its displacement along this direction. So this is the reason why we study trigonometry. It will gives us information about what part of one physical quantity about one direction have in some other direction, like what part of this velocity is along this direction. So let's start. So why we need why physics need trigonometry? So first, resolve vector into components. So whenever any vector is not in desired direction, we break that vector into different component in our desired direction so that we can calculate our desired quantity. Analyze projectile motion. We will study in first chapter of physics what is projectile motion. I think a basic of this you may be familiar with this or even not, no issue. Handle inclined plane problems, work with circular motion, understand simple harmonic motion or periodic motion, and analyze waves. When we'll study waves, whole waves are game of trigonometry. So actually all these are the need of physics which involve trigonometry. Without trigonometry, we cannot study all these things. So in short, if I ask what is physics, so physics is all about physical quantities which are of two types, one scalar and one vector, but most of the physical quantities are vector and which have magnitude as well as direction. How will measure direction? Like in normal life, we say that direction north, south, east, west, but actually there are infinite number of directions in a plane. Like suppose that I draw a plane. This is a plane. This is x-axis and this is y-axis. How many directions are there? There are infinite directions. Some this direction, this direction, this direction. There are infinite direction in a plane. So how we'll measure all these directions? So first we'll take some reference, like suppose that we are taking x-axis as some reference, and then we'll measure angle. Like if I am saying that at angle theta, means if this is our reference x-axis and some physical quantities are in this direction, it is making theta with x-axis, then we can say that this physical quantity a vector is at an angle theta from the x-axis. And we all know when angle is measured in anti-clockwise direction, the angle is positive. If angle is measured in clockwise position, it is negative. So here angle is measured from the x-axis in anti-clockwise direction, this direction. So this angle is positive theta. So direction is related to angle. Without specifying angle, we cannot study direction. So physics is related to physical quantities, and vector physical quantities have direction, and direction is found by angle, and angle will be dealt using trigonometry. Just like in normal life, we deal with numbers using algebra. In the similar way, angle will be dealt by using theories of trigonometry. So I hope until now you all are clear why do we need to study trigonometry, what is the use of trigonometry. Without trigonometry, physics is not possible. So let's start. So now if I ask you what is trigonometry, so actually trigonometry is the ratio. In short, we'll write trigo. Trigonometry is ratio of sides. Ratio of sides. And trigonometry is studied for right angle. So we can say trigonometry is the ratio of sides of right angle triangle. Right angle triangle. Right angle triangle. Right angle triangle. So here we have a right angle triangle which is right angled at B. B is 90 degree right angle. Now suppose that this angle is C and this angle is A. Now we have named all these. So if this angle C, we are taking angle C, then this will be called adjacent, and if we are taking angle A, this will be called adjacent. So angle, see, one is hypotenuse, which we can be identified very easily. The longest side of a triangle will be hypotenuse, and the side along with hypotenuse which is attached with that angle will be called adjacent. Like if we are taking angle A, this side is adjacent. If we are taking angle C, this will become adjacent, and the third side will be called opposite. So for angle A, this side BC is opposite, and for angle C, AB is the opposite. Now there are three sides, so there are three combination of two sides. See, ratio will be calculated for two sides. So there are three way we can pick any two sides. So there will be three ratio. First, sine. Hey, see, here we are writing all these ratio in term of angle A. So for angle A, AB will be adjacent and BC will be opposite, and AC will be hypotenuse. Side opposite to right angle is always hypotenuse. So sine of angle A is opposite by hypotenuse, means, see, trigonometry is ratio. So we have calculated ratio of opposite to hypotenuse, and that ratio we have called sine of that angle. So sine of A is a ratio, which is ratio of opposite to hypotenuse. Some people also call this as sine of A opposite. Some people call it perpendicular. Perpendicular. And divide by hypotenuse is hypotenuse. Similarly, some people call this, this opposite will be called perpendicular. I hope you all know this. And adjacent is called base. So sine of A will be the ratio of opposite to hypotenuse. Cos of A will be the ratio of adjacent to hypotenuse, or adjacent is also called base. So base by hypotenuse. So sine A will be opposite by hypotenuse, or we can write perpendicular by hypotenuse, P by H. Similarly, cos of A will be written as adjacent by hypotenuse, means cos A is the ratio of adjacent to hypotenuse. So it will become base by hypotenuse. And tan of A is the ratio of opposite to adjacent, or we can say perpendicular to base. So sine is all about ratios. Sine of any angle is ratio of two sides. Like sine A, ratio of perpendicular to hypotenuse, cos A, ratio of base to hypotenuse, and tan A, ratio of perpendicular to base. So there are three types of ratio which is defined in trigonometry. Now if we make this same in vertical position, same triangle is in vertical position. Now right angle here is at C, and here we are calling it, this will be called base, this will be called perpendicular. If we are talking about this angle is theta, and if let's take about this angle, okay, just this angle is theta. Now if we if we calculate about this angle A, then sine A will be perpendicular by base. For this angle A, this is perpendicular A, so it will be A by C. C is hypotenuse. Cos of A will be B by C. Tan of A will be A by C. In the same way, if we write sine of B, then what we'll get? C, sine of B. So for B, AC is perpendicular, means B by C. Cos of B, it will become A is the base, so A by C. I think you all have studied these basic things. And tan of B will become B by A. So these are the three ratios of trigonometry. I hope you all are clear with these things. Now there are three more ratios which is actually reciprocal of all these three. We will not call inverse. Why we will not call inverse? We will not call inverse. Why? Because inverse, see, all sine is ratio and they are also a function. When we write sine A, it means sine of A. A is variable and sine is function. When we will study function, we will know about this. But for now, just learn that this is a function. Sine is a function and variable is A. So function with variable A, sine A is a function. So we will not call inverse of sine A, but we will call a reciprocal of sine A, because inverse have some different meaning in function chapter. When we will learn about function, we will know it better. So for now, just don't call it inverse, just reciprocal. So we have three ratio: sine of any angle theta is equal to perpendicular by hypotenuse. In the same way, its reciprocal ratio is called cosecant. Actually, its name is cosecant, but in short we call cosec. Cosec of theta is just inverse of this, which is h by p. Similarly, we have cos theta. Actually, it is not cos, it is cosecant. It is cosec, C-O-C-E. This is cosecant and this is cosec, but in short we write cos. This is equal to base by hypotenuse, and its reciprocal, which is secant. In short we write sec theta. Secant of theta means sec theta will become hypotenuse by base. And third ratio was tangent, which we write in short as tan. So it was perpendicular by base, which will become its reciprocal will become cotec theta. Cotangent, C-O-T, it will become cotangent. Tangent, cotangent. Cotangent theta will become cot of theta will become base by perpendicular. So these are the three basic ratios, and these are the reciprocal ratios. So total we have six trigonometric ratios. What these trigonometric ratios tells us about? These trigonometric ratios tells us about the ratio of length of side of a triangle. Like suppose that we make a right angle triangle like this. This is 90 degree. Suppose that its length is x and this length is y and this length is z. Now suppose that we call this angle is theta. Now we can write for this triangle sine theta, sine of theta is equal to perpendicular. For this angle z is perpendicular. So z divided by hypotenuse y. So now all three are related. Theta, z and y, all three are related. So if two of them is known, third can be found. Now suppose that same triangle have some bigger form, like you all have studied about similar triangle in class 10. So same triangle have some bigger form, means its length will increase, angle will remain same. So sine theta ratio is not going to change, z by y will remain same. So if sine theta is known and any of these two sides is known, then we can calculate the third unknown quantity. This is the most appropriate use of trigonometry here. Similarly, if you want to use cos theta here, we can write x by y. And if you want to write tan theta here, we can write z by x. Now, if we know length of side of a triangle, like suppose that we have a triangle, this is a triangle, we know its length is 10 centimeter, its length is 8 centimeter, and its length is 3 centimeter. Actually, it looks like opposite thing. So let's take it as 6 centimeter and it as 3 centimeter. Now, if we want to calculate this angle theta, we can write sine theta is equal to perpendicular 3 and divide by 10. Similarly, if we want to calculate cos theta, we can write 6 by 10. So when we will find theta from this equation and we will find theta from this equation, both will give the same result, because all these things are related. Now we'll try to emphasize what does it mean, what if theta is equal to 0. So just think about this. Suppose that we have a triangle, it became like suppose that we have a triangle. This is right angle, means this is 90 degree. This is 90 degree. Now this is the angle which we are dealing with. So for this angle, this will be perpendicular, this will be base, and this will be hypotenuse. Now if we say theta is equal to 0 degree, not is equal to tends to 0 degree, this symbol is tends to, means it is not equal to but very close to. When we say that this symbol is tends to, when we say that theta tends to 0, it means theta is almost 0, little more than 0 or little less than 0, but almost 0, so it can be taken as 0. So if theta tends to 0 means theta is almost 0, what will be the value of p? Can we say that p is equal to 0? Because when this theta, see, theta decreases means this point will come down, this point will come down, this point, let's name it a, b, c. So in this triangle, when this point c will come down, theta will decrease, and when theta will become 0, the c point will almost overlap with point b. So in that case, p will become 0. What about b? Can we say that in the same case b will become equal to h, because now when c is overlapping with b will become equal to h, b will become equal to h. Now what will be the value of sine of theta? Can we say sine of theta will be 0? Yes, when perpendicular is 0, whatever be the value of hypotenuse, 0 y hypotenuse will be 0. Can we say cos theta will become 1, because now cos theta is base y hypotenuse and base hypotenuse both are same. So cos of theta will become 1 if theta is 0. All these things we are writing for if theta is 0. And what will be the value of tan theta? Again, tan theta is perpendicular by base, and we already know perpendicular in this case will become 0. So if perpendicular became 0, we will get 0. So from here very easily we can find the value of sine 0, 0, cos 0, 1, and tan 0, 0. So we have found the value of all three quantities. When we know all these three quantities, we can find the value of all three reciprocal ratio value too. So let's now focus on all three only. So sine 0, 0, cos 0, 1, and tan 0, 0. So this is how we will find the value of all these quantities. Now let's check for 90 degree. Now the same triangle we are taking it became tilted little, so let's make it straight line. And this is our triangle. This is our triangle A, B, and C, and this is the theta angle which we are dealing with, and this will be called perpendicular for this angle, this will be called hypotenuse, and this will be called base. So for this, if now theta tends to 90 degree, 90 degree, or we can say pi by 2. We all know 90 degree is also written as pi by 2. We will study about radian and theta relation, how to define radian. All these things we are going to study in this lecture series. So if theta is equal to 90 degree, see, if we want this theta to be 90 degree, what we should have? See, this C point should go in left direction. If we want to increase the value of theta to 90 degree, so this C point should move in left direction. So see, this C point should move to here, and this C point should go here. This C point should go here at this point. This is the new C, and in that case this angle will become 90 degree. So now tell me, when C will reach here, what will be the value of this base? Of course it will become 0 degree, 0. If C reaches here, what will be the value? In this case, two lines will overlap each other. This is hypotenuse AC, and since this point reaches here, B will also overlap here. So A and B will overlap. To bring C just above A, B and A will overlap. And when A and B will overlap, the length of AB will become 0. So in this case, B will become equal to 0. Again, I am not writing equal to because we are not discussing exactly at 0, because in that case triangle will not be defined. We are discussing tends to, close to 0. So if theta is close to 90 degree, B is close to 0, and these two are overlapping. So AC is equal to BC. AC is hypotenuse and BC is perpendicular. So perpendicular will become equal to hypotenuse. Now what is the value of sine theta? Means sine 90 degree. Theta here we have taken as 90 degree. So sine 90 degree is equal to See, perpendicular and hypotenuse are both equal. We all know sine theta is equal to perpendicular by hypotenuse. So it will become 1. Perpendicular by hypotenuse, both are equal, cancel out 1. What will be the value of cos 90 degree? So we have seen if theta is 90 degree, b will become 0. AB is 0. So it will become 0. 0 by hypotenuse 0. And tan theta, what will be the value of tan theta? So see, here base is 0. We write tan theta as p by b and base is 0. So it will be p by 0, which is not defined. Why not defined? In mathematics, any finite quantity means which is not very large, which is not infinity. Any finite quantity should not be divided by 0. So it is not defined. So tan theta at 90 degree is not defined. Always remember, at 90 degree, at 90 degree, tan is not defined. Tan is not defined. Tan is not defined. So I hope this is clear to all of you. So see, without any new theory, we have calculated the value of sine 0, cos 0, tan 0, sine pi by 2, cos pi by 2, tan pi by 2. So all these values we have calculated without using any new theory, just using simple geometry and our logic. Okay, now we will see some more values. Like here you can see this value you have to remember. I hope you all have remembered in class 10th too, but still you have to revise this again. Sine of theta 30 degree or pi by 2 is 1 by 2, 45 root 2 by 2, or we can say 1 by root 2. Sine 60 root 3 by 2, all these values you have to remember. And for this value, triangle is given like this. So if this angle is 30 degree and perpendicular is x, so hypotenuse will be 2x and base will be root 3x. This is the relation. Once we fixed the angle 30 degree, now the triangle side will follow a particular ratio. Like suppose that here we are taking the same angle 30 degree. Now when we'll form the triangle, suppose that we fix one side. This angle is fixed 30 degree and this side is fixed x. Now these two sides will automatically be fixed because this angle will have some particular value. When we'll take sine or cos or tan of this angle, it will have some particular value, and that value will gives the relation between this and this perpendicular base hypotenuse and perpendicular hypotenuse. So if one of these is fixed, now all values are automatically fixed. So see, we all know sine of theta is perpendicular by hypotenuse. So sine of 30 degree here given as half, means this, suppose that this is perpendicular and this is hypotenuse and this is base, and so sine 30 is equal to half. This is sine 30 is equal to half, which is equal to x by hypotenuse, perpendicular x by hypotenuse. Now from this we can very easily say that from this hypotenuse is equal to 2x. So this will be 2x. Similarly, if we use here tan relation, tan of 30 degree, find from here what is the value of tan of 30 degree. Tan of 30 degree is 1 by root 3 and is equal to perpendicular by base, means x by b. So from here very easily we can say b is equal to root 3x, means this side is root 3x. See, one angle is fixed, one side is fixed. Now we can calculate all angle, all sides. Once all sides are known, we can calculate all the angles. So just with one angle and one side, we can calculate each and everything about a triangle. So trigonometry is a very beautiful topic. So now we are going to logically see that what trigonometry means, like in physics, particularly in physics. Like suppose that see this picture. Suppose that we have some force which is acting in a direction which is making 30 degree from the x-axis. Now we want to calculate what part of this force is along x-axis and what part of this force is along y-axis, because this force is neither acting along x-axis nor acting along y-axis. Now we want to calculate what part of this force is along x-axis. Like suppose that we want to study effect of this force along x-axis, so we have to calculate its part. In physics we don't call part but we call component. So we have to calculate what component of this force is along x-axis and what component of this force is along y-axis. So how we'll calculate? So we'll try to complete a triangle, this triangle complete. Now if this triangle is, this angle 30 degrees is considered, clearly this will be called perpendicular, this will be called base, and this will be called hypotenuse. And when we are saying that F force is acting along this side, means this side length is F. Now we can write cos of 30. Now why we are writing cos, why not sine, why not tangent? Because we have to calculate this base, we have to calculate value of this base. We want to know what component of this force F is along the x-axis. So we want to calculate the value of this base, and value of this hypotenuse is known. So from all 6 trigonometric ratios, or even from all 3 trigonometric ratios, we have to find that trigonometric ratio which have relation between base and hypotenuse, because we have to calculate base and we have the value of hypotenuse. So which trigonometric ratio have relation between base and hypotenuse? It's cos. So we'll write cos of 30 is equal to base by hypotenuse. So base by hypotenuse, hypotenuse is F. Now we'll find what is the value of cos 30 degrees. So cos 30 degrees root 3 by 2. So we'll put here cos 30 root 3 by 2 is equal to base by F. So from here we can say F is equal to root 3, B is equal to root 3 by 2 F. Means if F force is applied in this direction, which is making an angle 30 degree from the x-axis, its root 3 by 2 part, means root 3 F by 2 will be along the x-axis. And similarly, if we want to calculate what component of this force will be along y-axis, then we'll complete this part. Now in this triangle, see, if this is 30 degree, this will also be 30 degree. How? Alternate angle. So now if this is 30 degree, this is 30 degree, for this angle, this 30 degree angle, this will be considered as perpendicular, this will be considered as base. So now we can write sine of 30, whose value already we know, half is equal to, in this triangle, call it O, in this triangle, uh, sine 30 degree will be P by B, P by H, hypotenuse. So P divided by hypotenuse, which is F. So from here we can clearly say P is equal to F by 2. Means if F force is applied in a direction at an angle 30 degree from the x-axis, root 3 by 2 F will be along x-axis and F by 2 will be along y-axis. Now just think, suppose that two values are there and both are perpendicular to each other. This is root 3 F by 2 and this is F by 2. So from Pythagoras theorem, sum of square of these two should be hypotenuse, which is F. So let's check. First take a square of this. Square of this F by 2 will become F square by 4, plus square of this will become 3F square by 4. When we'll add them, 4F square by 4, which is actually F square. And when we'll take its root, we'll get F. Means if we calculate hypotenuse for this, we'll get back this F. We get back this F. You will all remember that Pythagoras theorem. So these two, see, in algebra we directly add two numbers, but here we cannot directly add. These two are at 90 degree, so they will be added like a vector. We'll study about these things in detail when we'll start a vector. Here we are studying maths needed for physics. So I hope now you all are clear what does it mean by component of any vector, or why we are using trigonometry. We are not studying vector here, we are studying trigonometry. Why we are using trigonometry? Here, with the help of trigonometry, we have calculated what component of force will be along x-axis and what component of this force will be along y-axis. Without trigonometry, it was not possible. So in physics, we can study effect of any physical quantity in any direction. What will be effect of that physical quantity in a particular direction, even though that physical quantity is not acting in that direction? So that's why trigonometry is very important for physics point of view. I hope this is all these things which we have discussed is clear for all of you. This is for today. Next lecture we'll study about different angle, radian and theta, and we'll study a value of trigonometric function for all angle from 0 to 360 degree or even more than 360 degree. Thank you. Keep watching and keep learning. Thank you.